So Patches really enjoys Extrema, so he's sticking around for a little bit, it looks like. So I'll have to work around him. Okay, so I want to determine absolute value, so the first thing, of course, I have to do is take the derivative, and I'm going to do two things. I'm going to set that derivative equal to 0 first, and then I'll come back and set that derivative equal to undefined. So, of course, if it's set equal to 0, what that really means is that the top has to be 0, and I'm going to multiply that out as I write it out. So I would get a 2t cubed minus a 2t cubed, so that's going to cancel out, which means, here I'll write it for you. So I have 2t cubed plus 6t minus 2t cubed, and of course the t cubes, as I said, cancel out, so I get ultimately t equals 0. Then it'll be undefined if my denominator is equal to 0. So I have to think about, well, what will make that denominator equal to 0? And the answer is, if I square root and then I subtract 3, t squared equals negative 3. Well, nothing's gonna work, because anytime I square something, and I can't take the square root of a negative number, so this is a no solution. So far out of this entire interval on -1 to 1, the only value that I had was t equals 0. So I'll test that one, and I'll test the endpoints. I need to make a table. So here's a little piece of good news for you, even though I had to do this on the last problem and some yesterday. At the ones that were not my critical values, they were just my endpoints, I really don't need to check the derivative on them. That was just busy work, guys, sorry. So, but of course I know this one, it was when the derivative was set equal to 0. So these I don't really need to fill in. But I do need to find the y values. Remember, in order to find those y values, I've got to substitute into the original. So I'll have 1/4 and 1/4 and 0. And then I'm going to look for, well, which one is the highest? I'm thinking, oh yeah, it's the 1/4, and it's the highest one out of the list. So it's an absolute max. Oh, look, these guys tied. And the lowest one would be 0, so that's going to be my absolute min. And if I write them as coordinates, I'll have -1, 1/4, +1, 1/4, oops, and 0, 0. Pretty cool, huh? So I already got a head start on the next one, and you should probably pause and see if you can get to those values yourself without peeking and cheating. And remember that I need to worry about where it is that they actually meet up, what the slopes are from both sides. As a matter of fact, it might actually be useful to see what the graph looks like. Of course, this bottom one is a really skinny parabola, but that's only happening from 1 to 3. If I plug in 1, it would start at 4, and then it's going to be super steep all the way up to, what is that, 3 squared up to 36? I'm not going to draw all the way to 36. And then on the bottom I just have a line 2x plus 2, but that's starting with 0, and when I plug in 1 I do in fact get 4, so it is in fact continuous over that interval from 0 to 3. Okay, so if my derivative is equal to 0, well, the only piece that I can make equal to 0, 2 doesn't equal 0, so that's a no solution. And then I can set 8x squared equal to 0, and when I solve, I get 0. So there's one critical value. Of course, it'd be really great if I actually did that all correctly, right? Because we all know it's not 8x squared. I do still get 0. It was in fact 8x. But when x is 1, what I notice is the slope for the top function would be 2, sorry.